This video we will solve a question on price discrimination and how to find out the output in case of the price discrimination. The question is, a monopolist discriminates prices of its product in three markets and average revenue functions are, we have a monopolist and he discriminates the prices in three markets and average revenue in each market is being given by, that is average revenue in the first market is 42 minus 2 Q1. Q1 denotes the output produced in this market. Average revenue in the second market is being given. Average revenue in the third market is being given. Total cost is equal to 25 minus 6Q plus Q square, where Q is equal to Q1 plus Q2 plus Q3. That is output produced in each of the markets. We have to find out profit maximizing output to be sold in each of the markets and the price is fixed in each of these markets. Okay. So what we are being given here, what is average revenue? Average revenue is in fact the price. That is the price, what we call the inverse demand function of first market, inverse demand function of second market, and inverse demand function of third market. So let's write it in this case, what I can say in this fashion. So in place of average revenue 1, can I write P1, that is inverse demand function in the first market is 42 minus 2Q1. Okay, similarly inverse demand function in the second market, that is price in the second market will be equal to 66 minus 3Q2. Symmetrically AR3 means price, that is price in the third market will be equal to 64 minus 4Q3. Okay, these are the what we call the three markets. We need to find if this monopolist discriminates price, how much price he will charge in each market to maximize profit. Okay, so for this what will we do? We need to solve these markets for individually. Okay, and how do we solve? We equate marginal revenue with the marginal cost. Let us see what is the total cost. Total cost is equal to 25 minus 6. Q is equal to Q1 plus Q2 plus Q3. Can I write 6Q1 minus 6Q2 minus 6Q3 in place of Q? Okay, so I'm just trying to save the space, otherwise I can explain how it happened here. Plus we have Q, so again in place of Q we have Q1 plus Q2 plus Q3, but it is whole square. This is the total cost function. Now what will we do? We will find out the profit maximization condition in each of the markets. Okay, so let's take the first market. Okay, so in the first market what happens? We need to find out the marginal revenue. We equate marginal revenue with the marginal cost. Okay, let's first find out the total revenue in the first market. Total revenue in the first market will be equal to P1 into Q1. Okay, so P1 is this, so we can write 42 minus 2Q1. To this we multiply by Q1. Okay, let me solve it here. So total revenue in the first market will be equal to 42 Q1 minus 2Q1 square. Okay, simple thing, I will not go into detail. Marginal revenue in the first market will be equal to the change in the total revenue in the first market due to the change in the output of the first market. The derivative of this function with respect to Q1, derivative of Q1 is 1, so we are left with 42 minus Q square, its derivative is 2Q, so 2 into 2 is 4Q1. This is the marginal revenue in the first market. What is marginal cost in the first market? Marginal cost in the first market will be the change in the total cost due to the change in the output in the first market. Okay, we take the partials of this function with respect to Q1. Derivative of a constant is 0, derivative of Q1 in the second term is 1, so we are left with minus 6. Derivative of third term will be 0, of the fourth term it will be also 0, because we are taking the partials with respect to Q1. Now derivative of this term will be equal to, so first we apply the power function rule, 2 becomes coefficient, then we have Q1 plus Q2 plus Q3 times the derivative of Q1, which is equal to 1. So we can write the marginal cost in the first market will be equal to, for the firm will be equal to minus 6 plus 2Q1 plus 2Q2 plus 2Q3. Now profit maximizing condition requires that we equate marginal revenue with marginal cost. So marginal revenue in the first market we equated with the marginal cost of the first market marginal revenue is this function, so let's write it here. 42 minus 4q1, we equate it with this minus 6 plus 2q1 plus 2q2 plus 2q3. Okay, now solving this, what will we get? So transposing, let's do here one thing, transpose this here. So 2q1 plus 4q1 becomes 6q1, then we have 2q2 plus 2q3, transpose this here, so 42 plus 6 becomes 48. Okay, this is our one equation for the first market. This is the profit maximizing condition. Similarly, we need to solve for the second market. Okay, again using the same logic, that is let's take the second market in consideration. So again, for second market, what will we do? Let us take the second market. So again, we find out the total revenue function in the second market, which is P1 times, P2 times Q2. Okay, so this is P2 is equal to 66 minus 3Q2, to this we multiply by Q2. Okay, so total revenue in the second market will be equal to 66 Q2 minus 3 Q2 square. Now let's find out the marginal revenue in the second market. So marginal revenue in the second market will be derivative of this function. Okay, so derivative will be 66 minus 3 2s are 6 Q2. Okay, this is the marginal revenue function in the second market. Now what is marginal cost in the second market? So let's take, I will not write these things, so let me write it here. So the derivative of cost function with respect to Q2 this time. Okay, so total cost function was somewhere, so this is total cost function. This time we take the partials with respect to Q2. Okay, so derivative of the first two terms will be 0. Q2 is here, its derivative is 1, so we are left with minus 6 plus, again using power function rule, we get 2 Q1 plus Q2 plus Q3 times the derivative of Q1, which is 1. So marginal cost will be equal to minus 6 plus 2 Q1 plus 2 Q2 plus 2 Q3. Okay, again solving, equating marginal revenue with marginal cost this time. So we get 66 minus 6 Q2 is equal to minus 6 plus 2 Q1 plus 2 Q2 plus 2 Q3. Okay, now again, now transposing this 6 Q2 here, so what will we get? So we get first turn and, okay, let me write, we get 2 Q1 minus 6 Q2 plus 2 Q2, it becomes 8 Q2, then we have plus 2 Q3, transposing this here, it becomes so it becomes 72. Okay, so this is our now let us go for the second, rather for the third market. Again, for third market, again we equate total revenue, that is third market is equal to, rather total revenue in the third market will be equal to, total revenue in the third market will be equal to P3 times Q3. So P3 is this 64 minus 4Q3, to this we multiply by Q3. So total revenue in this third market will be equal to 64 Q3 minus 4 Q3 cube. Okay, so what is marginal revenue in the third market? That is 64 minus 4 3s are, sorry, it is here square, 4 2s are 8 Q3. Okay, now what is the marginal cost in the third market? Marginal cost in the third market will be equal to derivative of this function, again this with respect to Q3. Okay, so let me write it here, the change in the total cost due to the change in the, I am using the partials here, okay, with respect to Q3. So derivative of Q3 is 1, so we are left with minus 6 plus 2 times Q1 plus Q2 plus Q3 times 1, the derivative of this. So marginal cost in the third will be equal to minus 6 plus 2q1 plus 2q2 plus 2q3. Now setting marginal revenue with marginal cost. So marginal revenue is 64 minus 8q3. We equated minus 6 plus 2q1 plus 2q2 plus 2q3. Okay, again solving this. So transposing this here, so we will get, first I write 2q1, I am just saving the space here, plus 2q2 now to the plus 10q3 is equal to 64 plus 6 comes out to be, so which comes out to be 70. Okay, now let me further solve this, dividing both sides by 2. This equation, it is divisible by 2, so we will get let me rub this out now, because we have 3 unknowns and we need to find out the profit maximizing output in each case. So for that, what I need to do, we need to rub this out. Okay, and let me so we have this 6q1. If I divide it by 2, so I will get 6q1, dividing both sides by 2, I will get 3q1 plus q2 plus q3 is equal to 24. This will be one equation first, let us say. Similarly, we have this dividing both sides by 2, it is divisible by 2, so I will get q1 plus 4 q2 plus q3 is equal to 72 divided by 2. This comes out to be 2 3s are 6 and 2 6s are 12. This is equation second for the second market. Similarly, for third market, we got this dividing both sides by 2, so we will get q1 plus q2 plus 5 q3 is equal to 35. This is equation third. Okay, so we solved profit maximizing condition in each of the markets and we got 3 equations. Now we need to find out the profit maximizing quantity in each of the market. Okay, so for that, what will we do? Since we have 3 unknowns, we can use Cramer's rule here. Okay, or we can use matrix inversion method here. Let us use the Cramer's rule. To solve using the Cramer's rule, what we need to do, first we need to write these equations in this form, that is A times X is equal to B. Now what is A? A is the coefficient matrix, and let me write it here. A is the coefficient matrix. A is in fact the coefficients of Q1, Q2 and Q3. So coefficient of Q1 is 3 here. Coefficient of Q1 in the second equation is 1. So I can write here 1. In the third term, it is third equation, it is also 1. Here coefficient of Q2 is 1. Here it is 4, 1. Then we have 1. Here again 1. Here we have 5. Okay, we call this the coefficient matrix. So having 3 equations, we write them in this matrix form, that is A, which is the coefficient matrix, times X. X denotes the solution vector. Okay, and let me say what exactly is X. X is in fact the solution vector that we are supposed to find, that is the value of Q1, Q2, Q3. This is actually a column matrix. And B denotes the vector of constant terms. B will be equal to, let me denote B by, we have these constant terms, 24, or let me write it, we have 24, then we have 36, 35. Okay, in fact we have to write this in this fashion, or let me write it here. So in place of A, I have this matrix. Let me write it here. So let us write it in this fashion. AX is equal to B. So A is this 3 1 1 3 1 1. then we have 1 4 1 1 4 1, then we have 1 1 5 1 1 5 times x. X is the solution vector, that is equal to q1 q2 q3 should be equal to the vector of constant terms, and vector of constant terms is 24 36 35 24 36 35. I hope I am doing the calculation right. I am not responsible for any miscalculation here. Okay, so to solve the three equations in three variables, we first convert them into the matrix form, that is ax is equal to b. Then we second step is to find out the determinant of the coefficient matrix. This is our coefficient matrix. Let's find out its determinant. So how do we find out the determinant? Let me write it here. So determinant of a will be equal to, we write this term, okay, we write this 3, then mentally delete the row and the column in which it appears, okay, and multiply the resulting submatrix, the determinant of this matrix. So we write 3, then we mentally delete this row and this column. Then what will we do? We multiply these two elements. 4 5s are 20. Then we subtract and multiply with these two elements. That is 1 1s are 1. Then we write plus 1. Okay, whatever it is here, we write plus 1, and this time we write, we multiply it with. So first what we do, we mentally delete this row and this column. Then we are left with 1 1 1 5, and we do the multiplication. That is 1 5s are 5 minus 1 1s are 1. Okay, similarly then we write minus 1. So first we have plus 3, sorry, in fact I have done it incorrectly. So first we have plus, then we have minus, then we have plus. Okay, so we write 1, then we do mentally delete the row and the column in which it appears and take the determinant of this sub matrix. So we multiply 1 and 1 first, which comes out to be 1, and then subtract and multiply 1 and 4, that is minus 4. Then we need to solve this. So let us see what we get here. So determinant of a will be equal to, so here we get 3 times 19, then we have minus 1 into minus 5 minus 4 rather, sorry, we have minus 1 into 4, then we have plus 1 minus 4, which is minus 3. So 3 9s are 27, 3 1s are 3, 4 5 57. Then we have minus 4, then we have minus 3. So 57 minus 7, which comes out to be 50. That means the determinant of this matrix comes out to be 50. If the determinant was equal to 0, then the system of equations was not feasible, and then we could not have got the solution. Okay, since matrix is not equal to 0, we can find out the value of Q1, Q2 and Q3, which is what we call the profit maximizing our output in each of the market. So first we need to find out the determinant, which we've done pretty well, I guess. Now next thing is to find out the value of Q. Let me be very specific here. To find out the value of Q1, we replace the first column of the coefficient matrix with the vector of constant terms, okay, and form a new matrix A1. Okay, let me repeat it here. I cannot write it here because it will get very lengthy. To find out the value of Q1, we replace the first column of the coefficient matrix with the vector of constant terms and form a new matrix. Then we take the determinant of that very matrix, and then I will explain how to find out the value of Q1. Okay, so first we need to construct a new, to find out the value of Q star. What we need to do, we form a new matrix by, let us say it is equal to A1 is our new matrix, by replacing the first column with the vector of constant terms, that is 24 36 35. So other elements remain same, 1 4 1, then we have 1 1 5. Then we take the determinant of A1. Okay, again how do we take determinant? We write the first element, that is 24, then mentally delete row and the column in which it appears, then multiply these two, so we are 4 5s are 20, minus 1 1s are 1, then we write minus 1, then we delete the row and the column in which it appears, so we are left with these 4 elements, so 36 into 5, 36 into 5, then we have minus 35 into 1, 35 into 1, then we write plus this very element 1, then we delete the row and the column in which it appears and take the determinant of the remaining element. So we have 36 into 1, 36 into 1 minus 35 into 4. Okay, 35 into 4. When you solve this, we will get the value of A1 will come out to be, I have done the calculation, I am not pretty sure whether I have done it correctly there or not, so it will come out to be 207, I guess. Okay, now what will be the value of Q1? So Q1 will be equal to, Q1 star will be equal to the determinant of the new matrix that we find out, that is the determinant of A1 divided by the determinant of the coefficient matrix, which is A. Okay, so which is equal to 207 divided by 50. So this will be our profit maximizing quantity in the first market. Now to find out, okay, how do we solve using the Cramer's rule? First, we write the given system of equations into the matrix form Ax is equal to B. Then we find out the coefficient of the matrix, the determinant of the coefficient matrix, which come out to be 50. Then to find out the value of Q1, we delete the row, we replace the first column of the coefficient matrix with the vector of constant terms and form a new matrix A1. Then we take the determinant of the A1, which came out to be 207. Then we find out the value of Q1 by dividing this determinant of A1 with the determinant of the coefficient matrix, which came out to be 207. Similarly, what you need to do, because Azan is going, I cannot go further here. So to find out the value of Q2, what will you do? You form a new matrix A2 such that this time you replace the second column with the vector of constant terms. So we have 3 1 1 Jalla Shanahu. So this time we have 24, 36 and 35. Then you will write the same 1 1 5. Okay, then you take the determinant of A2. Okay, and then Q2 will be equal to the determinant of A2 divided by A. Okay, I left it for you people to find out the optimal value of Q2. Similarly, to find out the value of Q3, what will you do? You replace the third column of the coefficient matrix with the vector of constant terms. Okay, so you form a new matrix, that is, rather we write A3 only first. A3, we form a new matrix, that is, we have 3 1 1, 3 1 1, then we have 1 4 1, and we replace the third column with the vector of constant terms, which is 24, 36 and 35. Then what will you do? You will take the determinant of this A3. Okay, using the determinant, whatever comes out to be here, then Q3 will be equal to A3, the determinant of A3 upon the coefficient matrix. Okay, I could solve over this, but it will get very lengthy. Okay, so profit maximizing output to be sold in each of the markets will be Q1 will be equal to this 2207 upon 50. Similarly, you can find this step and this step to find out the price that will be charged in each market. So price in the first market will be equal to 42 minus 2 times the value of Q1 that we find out, which came out to be 207 upon 50. So solving it, so we will get 42 minus, we will get am I sure I have done it correctly? I guess. So we will get here, so 2 1s are 2, 25s are, I will get 207 upon 25. Solving further, if I can. So when you solve, so P will be equal to 42 minus 207 upon 25. This will be the price charged in the first market. Similarly, you can find out the price charged in other markets by solving for Q2 and Q3. I hope I make myself clear in this video. Thank you.